All right, today we're diving into one of the biggest public health challenges out there. It's been called a silent pandemic, and it's happening right now, kind of under our noses. This is serious stuff. It threatens to basically undo 100 years of medical breakthroughs and throw us back to a time when a simple cut could actually be a death sentence. Just think about this for a second. What if the medicines we completely take for granted, the ones that make surgery possible, that clear up pneumonia, that keep people with chronic conditions safe, what if they just stopped working? It sounds like something out of a sci-fi movie, but this is the very real threat we're going to unpack today. So to really get a grip on this whole thing, we need to meet the bad guys in this story, the so-called superbugs. So what are we actually talking about here? Let's start with the fundamentals. Okay, first up, antimicrobials. You can think of these as the miracle drugs of the modern age. Now, people have used things like herbal remedies for ages, but the game completely changed in the early 20th century with stuff like salvarsan and, of course, the big one, penicillin. These drugs were revolutionary. They became our #1 weapon against all sorts of infectious diseases. But here's the catch. The very thing that makes these drugs so powerful also creates this intense pressure on the microbes to survive. See, microorganisms, we're talking bacteria, viruses, fungi, the whole lot, they are absolute masters of survival. When you hit them with a threat, they adapt, they evolve. And that evolution is what we call antimicrobial resistance, or AMR for short. The microbes figure out ways to beat the drugs, and the ones that do, well, that's what we call a superbug. So how on earth do they pull this off? How does a tiny, simple microbe outsmart some of our most sophisticated medicines? It's actually a pretty fascinating and, let's be honest, kind of terrifying process. Let's look at their playbook, their battle tactics. Okay, tactic number 1 is the blockade. It's super simple but really effective. The superbug basically just builds a better wall. It changes its outer membrane so the drug can't even get inside to do any damage. It's like they've locked and bolted the door before the fight even begins. But what if the drug does manage to sneak past the defenses? Well, that brings us to strategy number 2, the pump. The microbe literally has these tiny little pumps in its cell wall that grab the drug and just shoot it right back out. You can imagine it like a tiny boat that's sprung a leak, and the crew is just bailing water out as fast as it comes in to stay afloat. Now, the third tactic gets a little more aggressive. Here, they disarm the weapon itself. The superbug starts producing these specialized enzymes that hunt down the antimicrobial drug and just destroy it. They chemically break it down so it's completely useless, a total counterattack. And finally, we have the disguise. So most of these drugs work like a key in a lock. They have to bind to a very specific target inside the microbe. What does the bug do? It just changes the lock. It alters that target site just enough so the drug's key doesn't fit anymore. It's a really clever piece of microscopic camouflage. And you know, it's so important to get this. This is not just about bacteria and antibiotics. That's what we hear about most, but antimicrobial resistance is a way bigger problem. It's affecting our ability to treat viruses like HIV, parasites like the one that causes malaria, and really dangerous fungi like Candida auris. It's a threat that cuts across the entire spectrum of infectious diseases. So we've covered the what and the how, but let's get to the real heart of it. Why is this such a big deal? How does a natural process like evolution turn into a full-blown global crisis? The most straightforward consequence is this. Infections that we used to consider minor annoyances are becoming really difficult and in some cases flat out impossible to treat. All these diseases we thought we had beaten are suddenly roaring back, and this time they have new armor. And the ripple effect from that is just huge. Think about it. So much of modern medicine relies on our ability to control infections. Without effective antimicrobials, routine surgeries, life-saving chemotherapy, organ transplants, all of these things become incredibly risky. The danger of a deadly post-op infection just skyrockets. And all this has a real, tangible, human cost. AMR means people are staying in the hospital longer, they're getting sicker, the costs of care are going up, and for way too many people, it means dying from an infection that we should have been able to cure. Okay, so it's important to remember that resistance itself is a natural process. It's just evolution in action. Microbes have always been adapting to survive. The problem is, our actions have basically slammed our foot on the accelerator, speeding this whole process up to a really dangerous pace. So what's adding fuel to this fire? Well, it's a few things. Poor sanitation and water quality can be breeding grounds for these resistant bugs. Not having good infection control in hospitals helps them spread like wildfire. But, there's one factor that stands head and shoulders above the rest. And this is it. The single biggest driver is how we overuse and misuse these incredibly precious drugs. Every time an antibiotic is prescribed for a virus, like the common cold where it does nothing, or every time someone doesn't finish their full prescription, we're helping the bugs get stronger. And the same thing is happening on a massive scale in agriculture, where these drugs are used not just for sick animals, but to prevent disease and even just to promote growth. I know, this all sounds pretty grim, but it is not a hopeless situation. The world is waking up to this, and we're starting to fight back. AMR is a complicated beast, but there's a clear, coordinated plan taking shape to deal with it. The World Health Organization has put together this big 5-point global action plan. It's a strategy designed to hit the problem from every angle. First, improve awareness so everyone gets the threat. Second, strengthen research so we know where the superbugs are. Third, just reduce infections in the first place with better hygiene. Fourth, get smarter about how we use the drugs we have. And fifth, and this is crucial, we have to invest in finding new medicines. One piece isn't enough. We have to do it all. So what does this actually look like in the real world? Well, it's about pushing fundamental things that we can all do, like just being better about hand washing. It's about innovation, like creating new vaccines so we can prevent infections from even starting. And it's about stewardship, making big, systemic changes, like stopping the routine use of critical medicines in farming so they'll still work for us when we really, really need them. And all of these different pieces lead to one really powerful central idea. We can't solve this problem by staying in our own little boxes. The health of people, the health of animals, and the health of our planet are all tied together, so the solution has to be connected too. That solution has a name. It's called the One Health approach. It's this recognition that you can't separate human health from animal health or the environment they both share. I mean, a resistant bacteria that starts on a farm can travel through the soil and water, end up on our food, and eventually find its way into our hospitals. It's all one big system. We have to tackle it on all fronts at the same time. Ultimately, pushing back against AMR is going to take everyone. We're talking policymakers, doctors, veterinarians, farmers, and every single one of us. It is truly a whole-of-society challenge. Which really just leaves us with one final and maybe most important question: what is our part to play in this fight? What can we do to protect these life-saving medicines for generations to come?